So I'm going to make a video explaining the shell method in a way that I understand it, and hopefully this can help other people too, because this has been difficult for me. So let's say that I have two functions that bound an area on the graph, this area, and we're going to rotate around the x-axis. So I'm going to have this top one be f of x, and this bottom one be g of x. So the first thing I like to do is draw the 180-degree reflection and kind of fill in this solid. So you can imagine this is going to be like a vase with a big conical gap in the middle. So the first thing that you're going to notice once you draw this reflection is which way you're going to integrate. Now after you've drawn it, it becomes very clear that this is the way that your cylinder is going to be placed. Right? You can't really integrate with respect to x here, because where would the cylinder go? You know. So once you have this, you can move here and say, all right, what is the radius going to be? Now this radius is just going to be equal to y, because from here to here is y. If you go up here, here to here, it's going to be y. Right, wherever this cylinder is just y. Now the height of this function, or the height of this cylinder, is going to be this one, right? Because if you go all the way, it'd be this whole thing. But then there's this little edge that's an overlap. So we want to get rid of that and only account for this amount. So I'm going to take this whole thing minus this thing. And this thing is the distance between the y-axis and f of x. So this is the length of g of x, this is the length of f of x. So my height is going to be equal to g of x minus f of x. Another way that you can see this, let me just redraw it up here. This is on the right side, and this function is on the left side. And when you're integrating with respect to y, it's going to be xr minus xl. So here's the right side because it's the longer length, here's the left side because it's the shorter length. Subtract the two and you get this smaller distance. And that's true for any point along this graph, you see. And there's your height and your radius. So when you set up the integral from points A to B, this is point A, this is point B. So if you're not given bounds, you'll have to set g of x and f of x equal to each other to see when they meet these points, so you get A and B. Then the formula is 2 pi times h times r, and we're integrating with respect to y, because our rectangle that we drew is horizontal, our cylinder is facing this way, and the axis of rotation is horizontal. So that's why we're doing it with respect to y. Let's say f of x was given to us as y equals square root x, right? Well, we want to convert this in terms of y instead. So this would be the function we'd be using. Let's say g of x was given to us as y equals 1/2 x, right? Then we'd want to convert this in terms of y. So then our height would become g of x, which is 2y, minus f of x, which is y squared. And we'd multiply by the radius, which is y. And then this becomes very familiar to all of us.